Hello everyone. Good morning. Welcome again to another product knowledge session for this week. For today, we're going to start with the EVS storage devices for streams backup. So for today, let's begin with this. Take a look at what we have for today. So the main theme for this EVS is just to ensure that we have this massive video storage in a smoother way and more reliable, just for the purposes of having our data protected and some other elements of data redundancy. Through this, let's go directly to what you're supposed to cover through the product, get to understand its product concepts and the solutions that can be offered by the EVS. So these are the contents. We have four part, but I'm going to skip the last one. We have the EVS device storage overview, that is. Then take a look at the EVS highlights, the EVS product types, and again, we close at that particular point. This is just some other successful cases whereby region has not been mentioned, though we have had some successful cases already. So once they have been mentioned, I'm going to include it to this documentation. So for the overview, take a look at the overview itself, advantages, and some solution application for this mass storage backup device. So this is a part of the overview whereby the EVS is rather embedded video storage, whereby it's one professional network storage product that we have and in distribution from Dahua. The EVS provides what we call a dual mode storage solution that is able to work both in what we call the IP storage area network mode and in the video stream direct storage mode. So a much more convenient and efficient method. So between the two, the IP SAN and the video stream direct mode, I'm going to explain to you when it comes to that particular part. So you can see from this particular EVS, we have different storage capacities. We have from we have 0 to 100 storage base. Then again, we have this other ability for recording and forwarding the capacity, whereby we have a high speed way of retrieving the data and storing the data through what we call the SAS technology. Then the EVS provides or maybe brings about this storage when it comes to system stability. The pricing, same time, it's not as high as expected. And then again, offers what we call the data protection, meaning that we have data redundancy to protect the data when it comes to, let's say, for example, areas to do with the fault tolerance. So we have the EVS, the NVR, and the cloud storage, whereby this can be summed up together to come up with a tangible solution for enabling you to have the devices doing backup of the video streams recorded from the various cameras that you have within different sites. So on this, the next part, take a look at the advantages of this EVS. So just going to highlight some of the advantages. That is the high system stability. There's high data security. There's powerful storage capacity and easy maintenance of the device itself. Going back to the high system stability, this device has multi-core processors that facilitate better performance compared to other storage devices. Has the IPC direct storage from simpler system structure, so meaning that you can have the cameras recording directly into the EVS device. Then again, provides this professional hardware design without any cables inside. So in this case, you're going to, let's say, for example, the mini SAS, if you want to extend the storage within the EVS itself. Then we have this redundancy of core modules, whereby you have the controllers, power supply, fans that ensure there's this uninterrupted services, because there's some EVS that contain two power supplies. And again, we have multi-controllers whereby one controller fails, another controller takes up the roles or resources to ensure that the device keeps on running. For high data security, that is going to be facilitated by other functions such as multiple RAID functions, such as RAID 0, all through to RAID 6.0. So we have RAID 0, RAID 1, RAID 5, RAID 6, RAID 1.0, RAID 5.0, and RAID 6.0. But the most recommended RAID um, function here to do the configuration, we just recommend RAID level 5. It's more stable, more reliable. So this EVS has single controller. EVS with single controller supports N plus M backup, whereby you have another device on standby just to ensure that even if the main device, that's the N, fails, we have the M backup device ready to take up the roles. Then we have this still again has dual controllers, support active, that is active dual controller, and hold standby functions, more or less similar to the system stability. Then this supports smart hard disk management functions, and then again, there's some that support automatic network replenishments. On the storage capacity for this EVS as an advantage, supports private, that is DAO products, supports ONVIF, and some other RSTP protocol access to, let's say, for example, third-party products with the private products. This supports up to 200 and 320 channels with the speeds of up to 800 megabits per second to 1024 channels with speeds of up to 2448 megabits per second. That's defined bandwidth. So this can support a maximum of up to 85 hard disks for mass storage. That is at the least being 16, all to the highest being 85 hard disks. And then again, on each and every of those hard disks supports up to 20 terabytes of either SATA or either the SAS enterprise hard disk. That is just another way of ensuring that there's this better system reliability and speed when it comes to reading and writing the data from the device itself. Then it supports the mini SAS extension. So if you feel like, for example, those 85 hard disks is not enough, you can add on more other hard disks by using a mini SAS extension. For easy maintenance ability, this EVS contains or maybe comes with the real-time monitoring and real-time alarm of the whole machine status. Let's say if let's say the network is that good, alerts you. If let's say, for example, some of the hard disks become faulty, or maybe some of the hard disks are not powered, same case again, it's going to give you some status. So to support on that, there's one key diagnostics, diagnosis of device statuses. Still on the easy maintenance, there's a pull-out design of the controller and the power supply, which is more convenient when doing the maintenance. So the hard disks, the number, depending on the number of the hard disks that you have on this EVS that is, they support hot swap function, whereby you don't have to reboot the device, so that maybe turn off the device for you to remove the hard disk. You just remove the hard disk, or the device is simply powered, and you can remove and return the hard disk just to ensure that you keep the device optimum performance and the reliability when it comes to doing the collective storage of the video feeds from the multiple cameras that are within that environment. Then the other thing, we'll take a look at the EVS solution applications. So in this case, there are two main solutions, and from those two main solutions, we have the most recommended solution. So we have the video stream direct storage and the standard IP SAN model, or the standard IP storage area network model. So in this kind of a video stream direct storage, we have all the IP cameras connected directly to the EVS. And then again, this EVS is connected to maybe linked to the DSS Pro, so that through this DSS, you can manipulate whatever we have within this EVS, or you can get access to the videos stored within the EVS. Similarly, you can still use the EVS web interface to access the video footages on this particular end. And through this DSS, you can still decode the multiple channels into one video. So for video event information, there's a picture from the IPCs can be directly stored in the EVS. And then again, the EVS can transfer the video streams to the DSS Pro, whereby you can use this DSS Pro to receive the IP camera's event information through the EVS. So you can see from this point, we still have the cameras, we have the NVR, still linked together to maybe connected directly to the EVS, so that you can still have backups on this NVR at the same time. So this can be the main, while this EVS becomes your backup storage location. So through this kind of a solution, it offers us a high performance features, offers you higher stability, and then again, it's very cost effective. So the second solution, that is the standard IP storage area network. All the cameras are basically going to be connected through the video management system, or the VMS. And then again, through the iSCSI protocol, we find that now the data can be pushed to the backup storage. So EVS is mounted to the platform as a network disk. So this is a more or less like a NAS drive, whereby you have the network attached storage. So you're going to attach the hard disks within the network, so that, let's say, for example, it's going to be available as one particular storage within the system. So EVS will only provide storage space, and the platform will forward the video stream from the IPCs to the IVS. So we find that we have these video streams on the either IVSS or the NVR. Then again, this is going to pull or maybe forward these video streams from this NVR or the IVS to the EVS through the IP-SAN or the iSCSI protocol. So these are the main two solutions from the EVS, but this is the most recommended solution, whereby you have all the cameras added to the EVS. So for the system highlights for the EVS, this is what you're going to take a look at in the next few minutes. Okay, so for the system highlights, the EVS provides with a professional hardware, whereby it's a modular-based, cable-less, and multi-redundant design to ensure that there's a system reliability. That is that ability of ensuring the device optimum performs. Then we have the device level failover. That is this function for N plus M device for fault tolerance, whereby the main device fails, the other hold standby devices become active to continue collecting the video feeds from the cameras. Same case again, we have the the storage extension, whereby this can support expansion cabinets and can dynamically expand the storage capacity when the storage capacity is insufficient. So you can use the mini SAS through, let's say, for example, the mini SAS architecture, just to ensure you can expand the storage for the devices. So through this, there's a direct storage of the video feeds, whereby it's more or less costly, easier to manage the devices, and simplifies how the servers are going to communicate when collecting the video streams from the cameras to, let's say, for example, the video the EVS. Same case again, this EVS supports AI IPC input. So we'll have multiple artificial intelligent enabled cameras input, such as, for example, the face recognition, face detection, people counting functions allowable within the EVS itself. So you can do AI search on the web, connected, let's say, the web interface of the EVS, or again, you can transfer them to the video management system or the DSS Pro for better manipulation. Then again, we have the RAID technology, which is another function within this, maybe highlight within the EVS, whereby this data will not be lost when the hard disk fails, simply because this supports multiple RAID functions, such as RAID level 0, level 1, level 5, RAID level 6, level 10, level 50, and level 6 0. So in those cases, you can choose one of those particular RAIDs levels, just to ensure that you can protect your data, and again create redundancy over the data, so that it is being well protected. So alongside that, the EVS, as one of the major highlights, is it's very easy to do the maintenance. We saw before the EVS are modular based. At the same time, uses less cables, and most of those particular hard disk, the EVS supports the hot swappable function, whereby you can remove the hard disk without switching off the device and replacing with either the fault-free hard disk so that you can continue doing your recordings on the device itself. So these are the major EVS highlights. For those who want, let's say, for example, to use the EVS as a backup option for their surveillance needs. So talk about the direct storage. This is just an example of it. So in this case, we have two types of modes. We have the traditional storage mode, and then again, we have the direct storage mode. So in this case, uh, either of the two is simply going to give you the best function or functionality, but we recommend the direct storage, whereby all the video camera or the video streams from the cameras are directly stored within the EVS, and this EVS is added to the video management platform, or you can access the data collected from the camera through the web platform for this device itself. So we have the video and the picture streams, both from the private products, that is the DAW products, or the OnVIF, that is through the third-party products, or the RSTP functions for collecting, for example, streaming features. Now, for the traditional storage, we had the video streams or the picture streams, first of all, going to the picture server or the streaming media, and then again through the iSCSI protocol or the NFS protocol, sending the data to the EVS through the either IP SAN or the IP storage in a network, or the NAS, that is the network attached storage on the platform itself. So in this case, this is the recommended mode, that is direct storage mode. So through this, you find that the EVS are going to give you the powerful performance based on the versions for the EVS and the number of channels that's supported based on the EVS itself. Going to give you more. That's the direct storage mode. Gives you better performance, powerful performance, gets you more stability, and then again, it's very cost effective, as not as expensive as the previous traditional storage mode, because this again, you don't have to have any kind of servers brought about in between the devices. So we have different types of EVS based on the models. We have the EVS 3 series, 5 series, 7 series, and 8 series. And each of these EVS supports different types of different number of channels. For example, the 3 series supports up to 256 channel. The 5 series supports up to 320. 71 series supports 512 channels. The 72 series supports 1024, and 82 supports 1024. So in this case, these are basically video stream direct storage from the cameras to the EVS. So for the EVS, giving that highlight for professional hardware is that you can take a look at the back side of the device itself. We have the redundant power. So just in case one link fails, there's another link just to power the device is powered. Then we have these redundant controllers. We have the first controller and the second controller. So in this case, these two controllers just facilitate that performance of the device. When one controller fails, then the controller just keeps running the device without any kind of issues. So this hardware is designed to have the modular design, whereby you have hardware modularization, that it's also going to support the hot swapping functions, which can help easily realize installation and maintenance. So let's say, for example, this controller is, let's say, for example, not working best, you can hot swap it and replace it with another controller. So supports cableless design. So you can see without any cable inside device to avoid static electricity and cable disconnection issues. So in this case, this is a compact device that comes with less cable design, either in or out as well. Then we have this module redundancy. You can see this. We have these modules. So supports all key modules. We have the controller, supports the power, and supports the fan, whereby they are redundant to ensure that there's this uninterrupted storage services when the component fails. So that's why we have redundant power. We have this part and the second part, the power, the fans. And again, we have these controllers. So you find that the one controller fails and that controller keeps running the system so that you avoid loss of video streams from the camera. So an example of an AI input, IPC input, is that we have our AI IPC. Let's say, for example, WizMind 5, WizMind 7 IPC series that supports multiple AI functions. All these are connected directly to the EVS. And then again, this EVS is added to the DSS Pro. Then again, to support both the private devices, such as our product, and the third-party devices. So in this case, this is one way to support multiple DAO AI event by IPC access and forwarding the data to different locations. So from the front-end intelligence, this supports IVS, that is including the tripwire, the intrusion, supports object abandon and object missing, supports crowd gathering estimation, supports loitering detection, parking detection, heat map, and this is only transferred to the DSS only. Supports a trip where people counting is. You cross a certain line, counts a number. Supports again in area people counting. You get into a certain area that has been drawn. So if you stay within that area, it's simply going to count you, count the number that have entered the area or exited the area as well. So this still support a face detection by camera. So that is a AI by camera and a face recognition by the cameras, because there's some cameras do not support face recognition, but rather support face detection. So, and then some other high-end cameras, they support, for example, face recognition. For example, the WizMind 7 series for face recognition. And you can find that we have this face detection by camera that is through the WizMind 5 product. So again, there's some other intelligence supported by this AI IPC, that is automatic number plate recognition by the ITC cameras. For example, the ITC 413. There's a crowd distribution map support. There's a PPE by camera that is only transferable to the DSS. So in this case, we have the PPE by camera that is through the WizMind 7 product. Say supports again smart tracking function. We have thermal ability. There's support for video metadata by camera, either for metadata for human, vehicle, or metadata or non-vehicle. Then we have the call detection functions support, smoking detection support again. Then there's a vehicle density that is only transferable to DSS. We have smart motion detection. And then again, we have the stereo analysis only transfer the DSS. So the DSS is the one can support stereo analysis, support vehicle density, will support PP by camera, support heat map function. So AI by input. So this EVS will support multiple functions supported by the camera itself. So whatever is not supported through the camera, the DSS Pro will take over and help you in having that done. Okay. So for the device level failovers, this is what makes this EVS more marketable and more sustainable within our markets. So we have, you can see from this image, we have the multiple front-end devices, different models for the cameras, for example, the fisheyes, the box cameras, the bullets, and the dome cameras. So in this case, all these are connected through this EVS via the LAN. And then again, to ensure that there's this better protection and security of the data, we have the N plus M devices. So the N ones are basically being the main devices or the main EVS which are running and running status, and the M, that is the sub EVS, which are always in standby status. So in case, let's say, for example, this device fails, the M device takes over, so that we have improved reliability and performance of our devices, just to ensure that at least we have better data collection through the cameras themselves. So as you can see from this point, the N plus one host standby for single controller. So what for this function to work is that the models, both the N models and the M models should be similar. So that's what we told you, that the model of the sub EVS models on this end should be this same as the main devices. So if they're not the same, it's not going to give you a better option. Then for this M plus M single controller model, this supports quick recovery, better stability and reliability of the devices. So, or not just devices, but rather the video feeds that are collected by multiple cameras on different ends. Then we have the active control mode for dual controller. So in this case, you can see we have active controller, another active controller. We have powers, dual power supplies, and dual fans as well. So in this case, the double controller are real-time active. When one is broken, another will continue working, avoiding any loss of video record. So this is only for dual controller model. So single controller model, that is not applicable, because if one controller fails, then the system is simply going to be rendered malfunction. But for the dual controllers, it's going to be effective enough for the failover features or functions. Now, for the RAID technology supported by this EVS, you can have multiple um, you can have multiple disks within the supported EVS, and then again from those multiple disks, you'll always going to spare one device to be the hot spare disk. So the EVS will support the following functions. The EVS will support the following functions. Support the different RAIDs. Support RAID level 0, RAID level 1, level 5, level 6, level 10, level 50, and level 60, as most people say, RAID level 10, level 50, and 60. So, but the correct term is just using the term 10, 50, and 60. So this feature greatly improves your device reliability of the data storage. So the best way for the EVS is always RAID level 5 because of some other advantages that comes with it. It comes to maintaining the performance of the device at the same time the reliability of the device. So if, let's say, for example, you have an EVS that supports 16 hard disks, you're only going to have, let's say, for the RAID recommended configuration, you're going to have only 15 hard disks. Then you're going to have one device, one hard disk being the spare hard disk. So this spare hard disk is going to act as the device is going to carry some parity data for all these 5 hard disks. So let's say, for example, amongst these 15 hard disks, one device fails, you're going to have this spare disk that's going to auto construct the data from the failed hard disk because it has some information about that particular hard disk. So this utilization efficiency, that's usually 75%. Now, if you have an EVS that has 24 hard disks, you're only going to use 23 of them, and then again, spare one hard disk for the spare functions. So same case again, if you're using 36 hard disks, you're going to have all the hard disk in use. Let's, for example, 35 hard disks, then having one spare hard disk. Same case again, if you're using 48 hard disks, these 47 are going to be applicable for collecting the data, while this one hard disk is going to be responsible for collecting all the information about the 47 hard disks. So it has the parity information. The parity information is just small information that contains multiple data information from these 47 hard disks. So you can see from this point, we have both various EVS series, whereby, for example, we have this 3 series 3224S. This has the 24 hard disk. This contain the SMR hard disks. Then we have the 5016. This uses the interface for the hard disk is just SATA interfaces. This 5124, we're going to use SATA interfaces. 7124, 36, and 48 hard disk can either use, for example, the SATA or the SAS interfaces. Same case applies to all these other series from 82, 24, 36, 48 series. So in this case, you can see from this point, the function, why we need RAID level 5 as the main best usable RAID on this EVS, simply because of the costing ability, the performance, and then again the reliability of the devices. So if I use this diagram here, you find that amongst all these, RAID level 5 is the most suitable when it comes to using the EVS from these multiple disks for multiple storages. Then we have the storage extension. So for this storage extension, if let's say, for example, we find that they say the 24 hard disk, the 48 hard disk, or maybe for example, 85 hard disk is not enough on a device, you can use the mini SAS storage extension. So just to ensure that you can add to multiple other hard disks. So we have the mini SAS interfaces just to connect to these other small mini storage media here to have the device collected to have more broader storage space. So in this case, it's easier to do the extension simply because we can use there's to extend storage space, no need to change the system topology. So all you need to do is just add the ESS, the expansion cabinet, and the SAS cables. So those particular SAS cables are the ones which are going to connect the main one plus the other extension storage. So then again, for this extension, there's a longer storage time and larger storage capacity. So the maximum expandable memory is up to 384 terabytes and can support 200 channels at 2 megapixel IPS recording for up to 192 number of days. So for these particular EVS models, uh, some can support the ASS model, some cannot support the ESS model. So in this case, this is just a basic expansion cabinets just to enable you to do storage expansion for the EVS to collect more uh, information from the front-end devices, that is the cameras. On this other end, again, we have the easy maintenance capability of it. So this is an interface for one of the EVS. So as you can see, you can get to see almost each and every component of the EVS itself. So if you go to maintain end of it, just like how you usually go to the maintenance part of the NVR, or let's say, for example, the XVR, the EVS itself has its own maintenance module whereby you can literally check on all the aspects of the device itself. You can take a look at all the remote devices connected. You can take a look at the RAID statuses that you've configured on the device itself. You can take a look at the record status of, let's say, for example, the channels that are connected to the EVS. You can take a look at the case overview. So in this case, it's usually going to give you just an outline of how that device looks like. Then again, you're going to be given some pointers just to ensure that at least you can get to know how the device performs. For example, we have an online pointer that's green. You have the error, there's a warning, or no, not detected at all. So this becomes more quite easily. For example, these are the numerous hard disks that you can have. If let's say this hard disk, assume all of them are online, but if one hard disk detects some errors, you're going to see an error flashing or the warning or not detected at all. Same case again for the power. So since, for example, one has redundant power, you find that uh, for the power ends, you're going to get to see either it's only online, let's say, for example, exception, or not connected at all, or maybe not detected at all. So in this case, just one of just through the web interface of the device itself, you can get to know the really how this device are really functioning. The same case again for the motherboard of the device. This is what you're going to get to see at the end of this particular point. So for these ones, we find that it's going to be easier to keep tracking of the device performance so that you avoid issues of um, device timeouts, or for example, issues with, let's say, for example, having um, irregular recording of the video footages. So from this point, you can see there's all system information shown from the front page, that makes it easy to do the maintenance for the users. You can always clear equipment status, simple and elegant. For example, this is graphical user interface design, just easier to get to comprehend. For example, if you want to go to the system resources, if you want to go to the logs of the devices, if you want to go to the intelligent diagnosis, maybe take a look at all the online users, or you can take a look at the device maintain functions. So there's a quick guide button. So it's like a wizard that helps you do basic configurations for all the functions within the device itself. This is brought about by this easier and a neat graphical user interface from the web platform. So the last part is take a look at, for example, the naming rule, the EVS family or the EVS product and the competition. And we'll have to skip that for now. Now, in this case, we have the EVS itself. That's the embedded video storage. And then again, the first part just detects the series of the device because we have 3 series, 5 series, 7 series, and 8 series. And then again, the second part here denotes the generation of that particular device. We have first generation to third generation. So by having third generation becomes more better compared to, let's say, second or the first generation, because this has better features and a more optimized performances and functions of the device. The third part, this is going to state the number of hard disks supported on that EVS. For example, in this case, this is supporting 24 hard disks. So we have hard disks starting from 16 hard disks through to 85 hard disks. So remember that each and every of these hard disks can carry up to, for example, 20 terabyte of disk capacity. Then we have this special function for the EVS. So we have a single controller, dual controller, and the dual processor. So if you see S here, it just plays that this EVS has a single controller. If you see a D here, supports dual controllers. And then again, there's an X, supports a dual processors for better powerful performances. Then we have this hyphen here, then followed by another character. So this is for the power. We have R supporting redundant power. So not all models will have, let's say, for example, redundant power. So if it doesn't have this, if this is a plain without this, for example, 724S, that shows that does not support redundant power. But if anytime it has a dash R, yes, shows that the device supports redundant power. Then this is the EVS family. We have the entry-level EVS, we have the cost-effective, the high performance, and the ultra-high performance EVS. So take a look at this. This is the 3 series, 5, 7, and 8 series alongside the top of this chart. So then again, going towards your left, towards the right, is going to show the number of hard disks supported on this EVS. So we have some supporting 16 hard disks. We have supporting 24 hard disks, 36 hard disks. We have 48 hard disks. And then again, we have 85 number of hard disks. So all models can support 10 gigabit optical fiber interface expansion, except the EVS 5016 S RV2. So in this case, this one do not support the 10 giga optical fiber, but the rest can support optical giga performance interface, fiber optical interface expansion cards that can transmit data at very high speeds of up to, for example, 1024 to 2048 megabits per second. So on this other end, we have the main features for the EVS72 series. So in this case, provides with a high density that is that can be comfortably fit within the 4U space with 85 hard disks and up to 382 terabytes. Support up to 20 terabyte large scale capacity enterprise level hard disk. So support for data, device and data security because of the multiple different support for the RAID levels from RAID 0 to RAID 6.0. Then again, we have this other function for the N plus M clusters and redundant power supply. So in this case, your data is more secure and replicated so that in the event one particular hard disk fails, there's another hard disk that contains the data from the failed hard disk. Support for high performance as well. This can support forwarding storage and forwarding of up to 1024 number of channels with roughly 2048 megabits per second through the private or on VFA protocols. That is through channels from the DAO products or some other third-party cameras. So same case again, when it comes to having this easy operational maintenance, this device comes with a sliding rail installation by default, which makes equipment status in one package for real-time monitoring, provides simple and elegant graphical user interface design. So in this case, this when you put this in a certain rack, you just slide it, then it's going to be fixed firmly. So if you want to remove it again, you just slide it outwards, then replace whatever you want to replace and have the device running as usual. So for the X82X series, that X can either be 16, 36, 24, 36, 48, etc. So it gives high performance. This has a dual CPU design. As you can see from this point, supports up to 16 GB of RAM that can be expandable up to 256 gigabits of RAM itself. When it comes to the transfer speeds, that can go to as high as 2014 megabits per second. This device supports a high stability because of the N plus M cluster for redundancy. At the same time, again, for data protection, support multiple RAID functions from 0 to 60, and then again supports redundant power supply. So in event one power supply fails, there's the other power supply, keeping the device running optimally. So there's a huge storage capacity. This can support up to enable customers to flexibly select to choose maybe different choice between 24 to 48 bay models. Then we have support for up to 8 terabyte large capacity enterprise level hard disk, and then again support scheduled backup. So in this case, you can schedule, let's say for example, you have backup, let's say at this particular interval of time, either during the day or most likely during the time when there's no much pressure for bandwidth utilization. That is um, racing between the device with some other devices that require to utilize the bandwidth. When it comes to the operational maintenance, the device comes the modular and drawer-like design, whereby you just slide it within the cabinets. Then this comes with a simple and elegant user interface, and you can clear requirements, equipment status on one page for real-time monitoring. So in this case, on the device web interface, you can monitor nearly all the operational function of the device, the hardware and the software are part of it. So with that, I'm going to conclude this product knowledge training for the EVS for bulk storage devices. So for those people who have different sites in different locations, you can still configure this so that all those particular sites can store their data within this single device. So for those who have different sites, this is a solution for you to have centralized storage of your data. So with that, if there's a question, kindly have it in the chat area. If there's no question, then I'm give you some time to share your details so that I can share this file with you at the same time as I populate the video so that I can share the link of the video for those who want to go through to listen to the audio of our today's training. So with that, thank you so much and enjoy the rest of the morning session. I believe it's afternoon already. So thank you. Let's meet again in the afternoon for another product knowledge.